Hello. In this problem, the length of the lattice rectum of an ellipse is given as 8, okay, and the distance between the foci of the ellipse is equal to the length of the minor axis, and then we are asked to identify which of these points lie on the ellipse. Okay, so so lattice rectum is the length of the focal chord which is perpendicular to the major axis. So that is the lattice rectum. Okay, so we know the lattice rectum L prime. If I take the equation of the ellipse as x square by a square plus y square by b square equal to 1, which is true in this case. Okay, so the major axis is along x-axis. So L prime, we know it is 2b square by a, which is given as 4. So from here we can say b square is 4a. Okay, so in order to answer this question, we are trying to get the values of a and b so that we have the equation of the ellipse, and then we can use the equation to check if these points lie on the ellipse. Okay. Now, what is the other information we did not use? The distance between the foci is equal to the minor axis. Okay, so let's say the other focus is here. So we know with respect to center, both the focuses, each focus is at the same distance. And if I take the semi-major axis as B, because the distance between the foci is equal to the length of the minor axis, then the distance of one of the foci from the center should be B. Okay, and there is another very important property of ellipse. If you take a point on the ellipse, the distance of that point, okay, the sum of the distance of that point uh, to the foci is equal to the length of the major axis. So here conveniently, if I take this point, okay, on the y-axis uh, and take the sum of these two distances, okay, so ps plus ps prime, this must be equal to 2a, and here obviously ps is equal to ps prime, so that means ps I can take it as a, and this is 90 degrees. So clearly from here, if you take a look at this right triangle, we can immediately write down that a is square root of 2 times b, so which I can substitute here. Okay, so I have b square as 4 into root 2 times b. So from here, either b is 0 or b is 4 root 2. So definitely if b is 0, I think we're going to have a line, so we are not going to take that. So b is definitely 4 root 2. So if b is 4 root 2, if I substitute here, I get a as 4 root 2 into root 2, so that is 8. Then what is the equation of the ellipse from here? We have x square plus a square, which will be 64, plus y square by b square, which is 32. So this is equal to 1. Now let us check one point by one point. So suppose if I am checking if the first coordinate lies on the ellipse, I'll just substitute the values here, and then I'll see that the left hand side is equal to 1. Okay, if I substitute x coordinate 4 root 2 square, so that is 16 into 2, so 32 by 64 plus y square, so 4 and then root 3 square 3, so 4 into 3, that is 12 by 32. Okay, so this can be written as 32 plus, I think if I make the denominator 64, so that's 24 by 64, and this is 56 by 64. So that means okay, so this is not going to lie on the ellipse. So let's check the next coordinate. Okay, so 4 root 3 square. Okay, so that is 16 into 3, 48 by 64. 2 root 2 square. So 4 into 2, 8 by 32. Okay, so here we have 48 plus 8 into 16 by 64. Okay, so this is 64 by 64, which is 1. So the coordinate 4 root 3 comma 2 root 2 lies on the ellipse. So that is the answer.